I hope all of you have spent a nice holiday in Eid Said al with your family. But I don't know where are the rest of the students. Only three students have logged class and the most of the students are absent. The number of the students is decreasing every week. You know why? Is there any special reason? Unfortunately, only only three students have comfortable and unfortunately cannot wait more. And as you know, we have not enough time, and we have to start class and let them to come class late. Okay, let me to start a new chapter as namely statistical process control, uh, an interesting and very applicable chapter. No, I haven't completed practical because uh, three chapter except today three chapter will remain will remain and generally I think we have four sections with today to complete timetable of course, and after that you should submit your project. Don't forget that. I sent earlier the format of project and subject of project. If you haven't started your project yet, uh, I recommend you form your group as soon as possible and start your project. Okay. Uh, Let me start class, and as I told you, the topic of new chapter is statistical process control. What's the meaning of statistical process control? If you work in manufacturing or service company, in both of them, the statistical process control is very important for a company to monitor the process of production or service to customers. You should control the process because if the process has a little problem, you should stop the process of production or service and check the default and try to solve them. Because if your process has problem, it will affect on the rest of process, and you will encounter a big problem. You will produce defect product or goods and defect service that lead to customers unsatisfactory. So you have to monitor your process of production or process of service to see whether it's working well or not. It means that you are producing, for example, a television or laptop. Everything in each process should be according or based on a standard that has been defined earlier for this process by engineers. For example, the engineers have designed the tools or based on some standards. For example, the length, the width, and the height of the product, and the weight, and something like this. You should, operation manager, you should control and monitor these standards and these measurements to see everything is going well. If the process of production or service has problem, you as an operation manager will recognize that or will identify that. How? There is a job in any company as namely a process control. You should choose sample among production in a regular time. For example, every half an hour, or every 1 hour, 2 hour, and 2 hour, every 2 hour, or every 3 hours. For example, it depends on you and your production and something like this. Okay, you should choose sample and go to laboratory and measure the dimensions, the weight, or something that should be controlled. For example, sometimes in your production or in your service, weight is important. Sometimes the temperature is important. Sometimes length, width, or something like this is important. The speed is important. So there is a variable that should be controlled. That variable should be monitored every 1 hour to 1 hour by operation manager to see everything is going well. If there is a problem and it's not, or that variable, for example, speed or temperature, is not your desire, it shows that something has problem. For example, the machinery has broken, equipment has broken, or sometimes labor has done a mistake somewhere. When you see the process is not under control, you should stop the process and examine the reason of the problem, machinery, labor, or something like this, and then try to solve them. Because if you don't do this, all of the product after this mistake or after this default go to wrong, and the rest of the production will be defective, and you cannot sell them, and you will be incurred high costs. So we want to be familiarized with some methods, as namely a statistical process control, to help operation managers to do this job. Who cannot see the slide? Only Mr. Mohammed Aziz cannot see a slide. What about rest of the students? Mr. Nawabi, Mr. Dr. Mubin, Mr. Ahadi, can you see the slides? Uh, I don't know what's the problem. The zoom of S-Lite is 77%. It's a standard for the screen. The S-Lite is, please let me go to the second slide. Can you see now? Can you see this one? Okay. Okay. Dear students, I want to ask you if you can contact to your friends, please ask them to attend class and don't miss them, and not to miss them, sorry, and ask them to not to miss class because they will be incurred cost because they have spent a lot of money and fee for the academy. It can be counted a loss for them. So I want to ask you, please tell them to come class and not to miss class. Thank you so much. But unfortunately, I don't know what's the problem. If another thing is, I have sent 3 PowerPoint to you. You can check your email. If you check your email, I sent 3 PowerPoints, 3 chapters to you. You can check your email and download them to study. Location strategy, supply chain management, and also this one. Okay, today. I just sent them. Location strategy, statistical process control, and also supply chain management. Okay. Statistical process control. As I told you, variability is inherent in every process. It's undeniable that there is variability in every process. For example, you cannot produce the products or the goods which are exactly the same. Some of them have a little difference. Sorry, for example, in size, in weight, and something like this. But this difference should be a acceptable range. For example, the weight is varying from one product to another. Okay. Okay. So, in order to monitor the process, the variability can be divided into two categories: the natural or common causes, or special or assignable causes, as you see in screen. The variables or the dimensions that you are going to measure it, monitor it, can be divided into two categories: natural or common causes, special or assignable causes. A statistical process control provides a statistical signal when assignable causes are present. Detect and eliminate assignable causes of variation. So, some of the variation in product or in service are natural. We cannot do anything because it's natural. But some of them is special or assignable causes. Special or assignable causes means it's for machinery or labor. Machinery has broken or labor is doing wrong. If special or assignable causes happens, we should stop the process. But natural or common causes is acceptable, and we can ignore it because it's natural. It's out of our control in company. So we deal with special or assignable causes, and we try to detect and eliminate them. So statistical process control are the methods is a method. A statistical process control are methods which are trying to detect and eliminate assignable causes of variation. Assignable causes or variation is because of machinery or labor and something like this that is our control, that is in our hand. But natural or common causes is not so. We can ignore it. Natural variation, also called common causes. Another name of natural variation is common causes. Affect virtually all production process. Expected amount of variation. Output measure follow a probability distribution, and for any distribution, there is a measure of central tendency and dispersion. If the distribution of outputs fall within acceptable limits, the process is said to be in control. We will be familiarized with concept of distribution in the future. When you measure the process control, when you measure the variable like temperature, speed, weight, height, length, or something like this, when you measure them, you put them in the graph and see whether they are in acceptable range or not. Acceptable range can be defined by engineers. For example, the engineers have measured and have calculated a specific temperature for your product. And they tell you if the current temperature change, for example, 2 centigrade up or 2 centigrade down, there is no problem. But if temperature change out of this range, something is wrong. You should stop the process and see why the temperature has changed more than this range or lower than this range. Assignable variation. Assignable variation, also called specific causes of variation. Special causes of variation. Special causes means it has happened for reasons like labor or machinery, and this is in our hands. This is because of us. It's not natural. Variation that can be traced to a specific reason. So this variation should be traced to a specific reason. It means that we should identify, identify and try to solve the problem. The objective is to discover when assignable causes are present, eliminate the bad causes, incorporate the good causes. If this cause is bad for us, we should eliminate. But sometimes the causes are good, and it causes the engineer change to the situation that has happened. Control charts. Control charts are the methods that are being used in statistical process control. In statistical process control, we use the control chart to monitor the process of production or service, to see everything is going well and there is no special causes of variation. There is no assignable variation. If the control chart show us if there is assignable variation or special causes, we should stop the process and try to solve them to prevent to producing defective product or service, to prevent to high cost. Constructed from historical data, the purpose of control charts is to help distinguish between natural variation and variation due to assignable causes, as you see. How operation managers monitor the process. As I told you, to do this, they should choose samples. For example, you are producing cake in your company. You are producing cake. The weight of the cake, for example, should be 200 milligrams. The weight of all cake, but we know that all of the cake cannot be exactly 200 milligrams. And there is a little difference among cakes. For example, one cake is 201 milligram, one cake is 199 milligram, one cake is 203 milligram, and something like this. We cannot produce all of the projects exactly the same weight, the same speed, the same temperature, and something like this. But as I told you, there is an acceptable range. All of the weight for cakes should be located in this acceptable range. For example, when the engineer has told operation manager the acceptable range is 5 milligrams. For example, the cake should be located in 205 milligram or 195. If all of the weight of cake are in this range, there is no problem. What if some cakes are producing, for example, 230 milligram, or one weight of cake is 150 milligram? It shows that there is something mistaken. There is a special cause or assignable variation that I told you. We should stop the process. We should turn off the machine and see why it's happening. How the operation managers do understand or realize there is happening wrong for process. They have to choose sample and go to laboratory and test every, for example, 1 hour to 1 hour. For example, your company is producing 2,000 cakes per each hour. Operation manager select, for example, 15 cakes among 2,000 randomly. Okay, randomly they choose 15 cakes and go to laboratory and put them on a scale and see the weight. Operation managers write the weight of these 15 cakes that has been chosen as sample. 1 hour later, they should do again. Yes, there is a standard slide. Please let me, I will tell you. If 1 hour later, operation manager do again and write down the weight again. They should repeat this process every 1 hour. Every 1 hour to 1 hour, they should select sample and go to laboratory and check and monitor the process of producing this cake. So, the control charts are used by operation managers to use the historical data. Historical data means the weight of the cake that has been written down every 1 hour to 1 hour by operation manager. They are the historical data. They should collect all of this data and finally they use the control charts to see whether process is under control or not under control. If the process is not under control, as I told you, it shows that something is going wrong. And there is a special causes or assignable variation. Types of data. With regard to your production or service, the data can be categorized into two groups: variable, attributes. Variables are characteristics that can take any real value, like temperature, weight, speed, accelerate, height, width, length, and something like this. They can be measured by a tool, for example, by a meter, by a scale, and something like this. They can be directly measured. They are variable, maybe in whole or in fractional numbers. Continuous random variables. But another data is called attributes. Defect-related characteristics classify products as either good or bad or count defects. Categorical or discrete random variables. All of them mean the attributes cannot be measured directly, and we cannot directly allocate them a value. For example, you cannot directly measure the level of hard working or IQ by a tool. You should choose a second tool by which that can measure these attributes. For example, you want to see who is more hardworking, working in your class. You cannot use tools to measure the level of hard working among the students, but you can use a second tool by which you understand who is the more hardworking. For example, the score or the mark that has been the mark in mathematical. A person who receives a good mark for mathematical is more hardworking. It shows it's more hardworking. And a person who receives bad marks for mathematics it shows that he or she is not as hardworking as a person who receives good marks. So hardworking is accounted for attributes. So the data can be categorized into variable and attributes. That variables can be measured directly by tools and can be allocated a real value. The value can be fractional or whole, for example, 2.3, 2.7. But attributes is not as same as variable. They cannot be measured by tool. They should be evaluated by a system. Central limit theorem. Central limit theorem means that when you collect the data, for example, when you collect the weight, when you collect the temperature and something like this, you should calculate the average of this data. For example, you have collected 15 data for weight of cake. You should sum of them, and then divide it by 15 to calculate average. The mean of the sampling distribution will be the same as the population mean, mu. Mu, as you see, each bar equal to mu. Mu is the population mean. Population means the number of the products that you have selected for test. For example, for cake company, when you select 15 cake, the population size is 15. When you select the 25 cake, it depends on you. The population size is 25. In statistical science, some standards are defined by researchers. One of them is a standard deviation. A standard deviation of sampling distribution will equal the population standard deviation, sigma, divided by the square root of the sample size, n. So mu or x bar and sigma x bar should be calculated by operation manager by science of statistics. Only you as operation manager should only be familiarized with concept of this and learn the formula. It's enough for you. From where this formula has come is related to the statistical scientists, because they have created this formula based on their experience and they are using them as operation manager. So we should learn two concepts: the average of the sample population size, for example, 15K, 20K, and something like this, and then we should calculate a standard deviation of sampling. Because we want to, a standard deviation means the deviation of the average, when you calculate the average, you see that all of the data are in the range of the mean average, or are located in the range of this average or not. We will be familiarized the next slide. Don't worry about that. Control chart for variables. Because the variables can be measured, like weight, like temperature, we use the control charts for them, for variables. For variables that have continuous dimensions, weight, speed, length, strength, and something like this, X-bar charts are to control the central tendency of the process. R charts are to control the dispersion of the process. These two charts must be used together. Okay, we want to start by method of statistical process control. As I told you, we use the control charts. We have 4 control charts that help operation manager to monitor the process of control. Sorry, the control of the process. X-bar chart, R chart, C chart, and P chart. Now we want to start with X-bar chart and R chart. X-bar chart and R charts are 2 control charts that are used by operation manager to monitor the process. How we should use them? These 2 charts, X-bar chart and R chart, must be used together. Pay attention to this point. X-bar chart and R chart should be used together. X-bar chart. Don't worry, I will tell you one by one. At first, X-bar chart. For X-bar chart, when we know sigma, when we know a standard deviation is defined by engineer. For example, sigma is 2, 3, and something like this. Engineer define the sigma for you as operation manager in company, and based on this sigma, you should use this formula. In X-bar chart, some data should be measured by operation manager. The first is the upper control limit, UCL. UCL equals X-bar plus Z sigma X-bar. And lower control limit equals X-bar minus Z sigma X-bar. X equals mean of sample mean, or a temporary value set for the process. Z number of control standard deviation. Sigma X, a standard deviation of the sample, equal to radical sigma divided by n. But unfortunately, in this slide, it has a little mess. Sigma X equals radical sigma divided by n. Sigma is population standard deviation, n is sample size. Okay. Z and sigma are given to you based on the standards that have been defined by engineer or managers. For example, they tell you the normal standard deviation should be 2. It means that Z should be equal to 2 or 3 or 5 or, and also sigma should be this number. When you are given these 2 numbers, you can use this formula to calculate upper control limit and lower control limit. UCL and LCL are 2 range are the acceptable range for your product. So the all of data should be located in this range, upper control limit, lower control limit. They are calculated by this formula, x bar bar plus z sigma x bar and x bar bar minus z sigma x bar. How we should use this formula? Now, let me give you an example. Please listen carefully to this. This is example. For example, you are working in a company, it's producing flake, oat flake. You know what is flake? Oat flake. Oat flake is, for example, is the flake of the, yes, flake. Flake is for wheat and or barley and something like this. Very good, yes, corn flake. Corn flake, exactly. For example, corn flake or wheat flake and something wheat that has been used for bread. It is raw material of bread that are planted by farmers. Exactly, very good. Children eat them a lot. For example, you are working in a flakes company. The weight for flakes is very important for them. For example, when you are producing the flakes, you should control the weight. So the variable in this company is important is weight. In our one, for example, at 9 o'clock, operation manager selects sample. For example, it has a cup. He or she has a standard cup and go to manufacturing and select sample. For example, 9 cup. He should 9 cup in our one. For example, 9 o'clock. He selects 9 cups of coffee randomly. Flakes, not coffee, sorry. He selects the 9 cup of the flakes randomly in machinery and go and take them to library to measure the weight. Cup number 1. In cup number 1, the weight of the flake is 70 ounce or 70 grams, something like that. Cup number 2 has a weight 13. Please look at the table on the left. This is an example in our one. Cup number 3 has weight of 16 milligrams. Cup number 4, 18. Cup number 5, 17. Cup number 6, 16. Cup number 7, 15. And cup number 8, 17. Cup number 9, 16. Because you have selected 9 cup, sample size or N is 9 for you. Because you have selected 9 cup, I repeat again. Because you have selected 9 cup, so sample size or sampling size for you is 9. N equal 9. When you measure the weight by scale, you should calculate the average or mean. When you sum these 9 numbers together and divided them by 9, the mean is 16.5. Okay. Look at the table on the left. When you calculate the mean or average this 9 cup, the number is 16.5. You should sum You should sum these 9 numbers and then divided them by 9 to calculate the mean for hour 1. Half an hour later, for example, half an hour later in hour 2, the operation manager do the same. But because of the lack of the enough space, we don't write the weight of select for hour 2, hour 3. We just write the mean of them on table right, on the right. When you see the table on the right, in hour 1, we calculated the mean for 9 cups 16.5. The other 2, operation manager repeat this process again. He or she selected 9 cups, take them to library, weight them, and then calculate mean and write the mean directly to this table, 16.8. In hour 3, operation manager repeat again and do again. The mean for 9 cups in hour 3 was 15.5. Okay. In hour 4, hour 5, hour 6, 7, 8, 9, 12 times this process was repeated by operation manager. And the mean of the 9 cups and the mean of the 9 cups has been written and has been calculated and has been written in this table. So we have historical data. In hour 1, the mean of the 9 cups was 16.5. Please look at the table on the right. In hour 2, the mean of the 9 cups became 16.8. In hour 3, it became 15.5. To end. Now we have 12 data. For 99.70% control limit, the Z equals 3 and the sigma, as you see, is equal 1. The sigma and the Z has been given to you by engineer or by manager. They are standards that should be used for calculating the acceptable range, upper control and lower control. Z can be equal to 3, 2, or 1, and also sigma can be equal to 1, 2, or 3. We have Z here, Z equal to 3. Please write down in the piece of paper, please provide a piece of paper now and write down this number. Z equal to 3. It has been given to you by engineer. Sigma equal to 1. The standard deviation is equal to 1. Okay. Now we have Z and we have sigma. And also we have X bar, not X bar bar. X bar is X when you put one line above X. When you put one line above X, it's X bar. When you put two lines above X, it's X bar bar. I repeat again. When you put one line above X, it's called X bar. When you put two lines above X, it shows X bar bar. What is X here? X is the variable that should be measured. Weight. Weight is X. The table on the left gives you X. The table on the left in hour 1. Each of these numbers, each of the weight of the oscillate is X for us. The 17, 13, 16, 18, 17, 16, 15, 17, 16. Each of them is X because they are variable. When you calculate the mean of this X, it gives you X bar. Yes, it can be changed. It can be changed. It's natural. I told you. It's natural. Yes, the sigma is there. No, the sigma is constant. The Z is constant. They have defined earlier by engineer. Which engineer or upper manager? The sigma and Z have been determined before because they have the standard table. Okay, the sigma and z have a standard table. Based on the table, engineer give you the z and sigma. Don't worry about that. You have z and sigma. Only know the concept. They are called the standard deviation. It's related to statistical science, and no need for us to learn the deep concept of them. Okay, each of them is x. When you calculate the mean of this 9 cup for other one is x bar. So the 16.1 for other one is x bar, not x bar bar. It's x bar. So please let me repeat again. In x bar chart, at first you have x. X is the variable you should measure. Weight, speed, temperature, and something else. When you calculate x, you should calculate x bar after that. X bar is defined as mean of x. When you calculate the mean or the average of this x, it gives you x bar, not x bar bar. So the table on the right, each of the x bar has been calculated in each other. For example, the x bar in other 1 is 16.1. The x bar for other 2 is 16.8. For other 3 is 15.5. Now, yes, and the 16.1 is the only for 1 over 1. In other 2, you should repeat again. You should select the 9 cup of the flakes, take them to library. Yes, 16.1 is x bar for other 1. In other 2, you repeat the process. It means that you should select the 9 cup again, take them to library, weight them, and calculate a new mean or new x bar for other 2. In other 3, you should repeat again, and you should calculate a new x bar for other 3. When you write down this x bar in this table, the table on the right shows the x bar for each other x bar. As a sample, as an example, I just draw a table for other 1. For other 2 and other 3 has not been shown in this slide because there is not enough space for all of them. Only as an example, as a sample, I show you the other one that you understand what's happening for the mean and how x bar is calculated in each other. After calculating this, now in the formula, yes, exactly, very good. The x bar bar is the mean of x bars. Now you should calculate for the formula x bar bar. Let me show you again. In this formula, we need to calculate x bar bar. But in order to calculate x bar bar, at first you should measure the x, then you should calculate x bar, and finally you should calculate x bar bar. Here we measure the weight of x. We calculate x for each cup. Then we calculate x bar in each other. Now, in order to use formula, we should calculate x bar bar. UCL or upper control limit is the acceptable range. It's a formula for x bar chart method. It is used for all of the company and service. Okay, it's the same formula UCL, but it only varies. It only change. Sometimes it is weight, sometimes it's temperature. It depends on the company you are working. In this company, weight is important. Now, x bar bar. If you Sum is 12 number because we have 12 hour and then so we have 12 number. Now over 1 mean is 16.1. Now over 2 16.8. If you sum these 12 number and then divided them by 12, you calculate x bar bar. Very easy. X bar bar, if you calculate this by calculator, the number is 16, exactly 16. So select 16. So if you sum this 12 number and divide this 12 number by 12, you can calculate x bar bar that is needed for the formula. Okay, we have z, we have x bar bar. We should calculate sigma x bar. Sigma x bar, if you remember, has a formula: radical sigma divided by n. Radical sigma divided by radical n. The sigma and n, the both of them are under radical. Radical sigma divided by radical n gives you sigma and this x. Okay. N was population size 9. Radical 9 is 3. Sigma is 1. Radical 1 is 1. So x bar bar plus z sigma x bar equals x bar bar is 16 here. Z has been given to you 3. It has been shown under table on the right. Z has been given to you equal 3. Sigma x bar has been calculated by radical radical sigma divided by radical n. Radical sigma is radical 1, that is 1. Radical n is radical 9 because n is 9 here. Radical 9 equals 3. 1 divided by 3 multiply 3 is give you 1 plus 16 give you 70 ohms. So we have calculated upper control limit or the upper range for the upper control limit. Lower control limit is the same. We have not written the radical, but in this slide there is radical. You see the radical, but unfortunately it has a little mess. The radical is behind sign of equal. The radical should be after sign of equal. Radical sigma divided by radical n. This is the formula. See the formula for sigma and this x. Sigma and this x is defined as the standard deviation of the sample equals okay, please let me it take 1 minute. Radical sigma divided radical n. Because in chat I can show the sign of radical. It gives you sigma and this x. Okay, radical sigma divided by radical n. In this example, sigma is 1. So radical 1 is 1. Divided by radical n. N is 9. Radical 9 give you 3. 1 divided by 3. As you see, 1 divided by 3. It has been written in the parentheses. 16 plus 3 multiplied 1 divided by 3 equals 17. 16 minus 3 multiplied 1 divided by 3 gives you 15. The range of the X bar chart has been calculated now. 15 and 17. Now we should draw the chart. We should draw the chart. Okay. In order to, the chart has two axes. The vertical axis, yes, very good. Yes, exactly. Radical sigma, because sigma is 1. Radical 1 is 1. Divided 1 divided radical n. N is 9. Radical 9 is 3. So it gives you 1 divided by 3. 1/3. Now we should draw the chart. Chart has two axes. Is a coordinate system. Okay. The vertical axis is the mean. Is the X bar. The horizontal axis is the sample number or sample hour. The number of the hour you have selected sample. It's a standard for all of the X bar chart. We are drawing the charts. Okay, we are drawing the X bar chart. If you see, okay, the vertical axis is X bar. The vertical axis is X bar always. And the horizontal axis is the number of the sample or number of the hour you have selected. For example, in the hour one, the mean or X bar was, have a look at this table, 16.1. Number 2 or hour 2, 16.8. Look at the table of X bar, not X bar, X bar. The table on the right. Number 3, 15.5. If you draw the table and write this point on the right place, for example, in the other one, if you see, it's 16.1. The blue line, the blue dots are means in each hour, or X bar in each hour. In the hour 1, hour 2, hour 3, hour 4, or sample number 4, give you it. And in the vertical axis, as I told you, is X bar. So the X bar chart is a coordinate system which has two axes. The vertical axis is X bar and the horizontal axis is sample number. Okay, LCL is 15. You should draw a horizontal line that crosses the 15 in the vertical axis. Because we have not enough space. But at home you can select, you can start from 1, 2, 3, 4, and go up to 25, 26. But we have not enough space. We have to start from 15. Okay. But it's clear. You should draw a line, horizontal line that cross the 15 in vertical axis. It shows the LCL or level control limit. And also you should draw the UCL. UCL was 17 if you remember. No, UCL is 17. You draw a horizontal line that cross the 17 in horizontal line. And also you should draw the X bar bar. X bar bar is the line between UCL and LCL. As you remember, X bar bar was 16, as I told you. Look at the formula. X bar bar was calculated as 16. What was the X bar bar? X bar bar was mean of X bar. When you calculate the mean of the table on the right, you can calculate X bar bar. That was calculated because lack of the enough space. We wrote directly the number 16 in X bar bar. But you'd understand the X bar bar is the mean of X bar. If you see the chart, the X bar bar or mean of the X bar is 16. That has been exactly a line between UCL and LCL. Always X bar bar is a line exactly in middle of UCL and LCL. Don't forget that. X bar bar is always in middle of the UCL and LCL. It's clear because X bar bar is the mean of the UCL and LCL. When you draw this chart and put the spot on this chart, you see our number one. The mean was 16.1. We determined this blue spot on this table. Our two was 16.8. It was near to 17. Number 3 was, for example, 15.5. We did draw it. And all of them have been drawn this. Now, we have selected, we have determined, or we have calculated the range or acceptable area. The acceptable area is between LCL and UCL always. But if you see 3 point or 3 spot, number 10, number 11 and number 12 are in both of these acceptable range. Number 10, number 11, because number 10 is less than 15. Yes, 14.8. Look at the table on the right, number 10. And number 11 is 14.2. It's less than 15. Number 12 is 17.3. It's above the more than the 17. It shows the operation manager the process is not under control. It's out of control. So there is a variation of assignable or there is a special causes. So operation manager has to stop the process and examine what's the problem to solve it. The problem can be for labor mistake or machinery and something like this. It's a method. I think I told you the control charts are the methods that should be used by operation manager to monitor the process. We have 4 control charts: X bar chart, R chart, C chart, and P chart. Now we are talking about X bar chart. X bar chart means that at first you should select your variable, temperature, speed, weight, or something like this. Then you should choose sample randomly and take them to laboratory. Take them to laboratory. No, you don't need to do with the result. The result only show you the process is under control or not control. After that, when you see your process is not under control or is out of control, you should go and check the mistake. There is something wrong. Labor wrong is can be because of the labor and because of the machinery. It's up to you to select the randomly your population or sample size. You can, for example, measure the variable every 1 hour to 1 hour, every half an hour to half an hour, 2 hour and 2 hour. You can select the randomly the population or sample. For example, in this sample, we select 9 cup of the flake in each hour. Operation manager selects 9 cup of the flake and take them to laboratory and measure them on the scale and write down its result. Because we want to see the process is under control or not under control. Under control. This is the method. It's the method of the X bar chart. It's the standard. It has been defined earlier and you should follow it. If you want to use the X bar chart, you should follow this process. At first, you should select the you should select the population in a regular time, half an hour to half an hour. When you select the population and take them to laboratory, we should measure the X. Yes, exactly. Then you should calculate the acceptable range that are called UCL and LCL by formula. We talked about the using this formula, how you should use the formula, how you should calculate X and then X bar and finally X bar bar. Because in formula we need X bar bar. Yes, very good. When you see something is not under control, you should check the time and find the problem because there is some problem because they are not under control. As I told you, if you don't check the problem, the process go to wrong and you will produce the defective problem. For some production, it's dangerous. For example, in electrical devices such as the laptop and something like this, it should be monitored frequently to check the size of the components and something like this. Okay, so the X bar chart is used by all of the managers. X bar chart used by all of the managers, and it's a standard for every production, for every manufacturing, automobile manufacturing, food manufacturing, uh, clothes manufacturing, and something like this. There is the same standard, there is the same formula for all of them. Only the variable is different. For example, in this company, weight was important variable. It should be checked every 1 hour to 1 hour, for example. And they decided to select a 9 cup of coffee. So they decided to calculate a sample size equal to 9. So they selected the 9 cup of coffee, take them to laboratory, measure the weight, calculate the X bar in each hour, and in order to calculating UCL and LCL, they had to calculate X bar bar, and when you calculated UCL and LCL, you should draw the chart. When you draw the chart, you should identify UCL and LCL in the chart and go to table again and draw and specify the X bar and X bar in each other in the table, in the graph or chart, and see all of the X bar in each other are located in the range or not. If only one is out of this chart, you should see that the process is not under control and there is something wrong. Here in this PowerPoint I don't have the second example because we have not enough time. You know, time is the 7:33 now, and and on a three charts has been remained. Okay, so let me okay let me select the second example for you. Okay, let me second example. Let me. Okay. Uh, Please give me 1 minute to select a second example for you and upload it. But unfortunately, it takes the time. Uh, Please let me give this more examples the next week. Okay, next week in the first of class, we do the second and if you want the third example together for better understand. Okay, the next week we will do the more examples for each bar chart. Okay, the second approach for each bar chart. The example that we already done, we know Sigma. We knew Sigma. Sigma was one. But sometimes in some company, Sigma is not clear. We don't know Sigma. So there are another formula for calculating upper control limit and lower control limit for each bar chart. This formula has been given to you. In order to calculate upper control limit is x bar plus a and this a2 and this 2 multiple r bar, and lower control limit is LCS equals x bar minus a2 r bar. R is the average range of the sample that I give you. What is this? I tell you what is this. And a2 is the control chart factor found in table. A and this 2 should be chosen from table. There is a standard table for A2 and X is the mean of the sample mean. X bar. What is A and these two? Here you can choose the A and these two. It's called mean factor. When you have sample size n, according to your sample size, you should select A2 from this standard table. For example, because the sample size in our example is 9, okay, sample size in this example was 9, if you remember. So the A and this 2 is 0.337. Look at the sample size 9, the A and this 2 is 0.337. This method is exactly the same, but in this Example, we don't know how much is sigma. We don't know sigma, so we use this formula. A and the 2 should be selected from table. And what is R? R is range. Range means the difference between maximum number and minimum number in each sampling. For example, R is range. Range means the difference between maximum number in minimum number. For example, in hour 1, look at the table on the left. In hour 1, how much is the maximum number in this table in hour 1? No, maximum number. Look at carefully. Very good. 18. Very good. 18. And how much is the minimum number? Very good. 13. No, 13. Cup number 2 had a weight of 13. 13. What is the difference between 18 and 13? How much is difference between 18 and 13? The maximum number minus minimum number. Very good. 5. 5. Very good. This is range. This is R1 for hour 1. R1 is range for hour 1. We do exactly the same for hour 2, hour 3, hour 4, because in each hour we had 9 cup of plate. For hour 1, the range is 5. For example, for hour 2, the range was 6. For hour 3, the range was again 5. When you calculate the average range, you should sum this range together and divide it by 12, because every hour has its own range. When you sum this range and divide them by 12, you can calculate R bar or range. No. It's different. It's different. Range is defined as difference between maximum number and minimum number in each sampling or in each hour. It is defined in each sampling, but upper and lower limit defined for whole the hour, for 12 hours, for whole 12 hours. But range is defined. Yes, very good. Range is difference in maximum and minimum in each sampling. For example, in hour 1, the range was 5. For hour 2, hour 3, hour 4, each hour should be calculated for each. Range means the difference between upper number and lower number in each sampling, or maximum or minimum number in each sampling. It means range. Okay, very nice. When you calculate range for each hour, R bar means average of the range. You should sum the range together and divide them by 12. You can calculate R bar. Okay, now in this formula, for example, yes, second method for each bar chart. For example, the process average in one example is different. This example is different with first example. I wrote for you in chat. Range equal maximum number in each sampling minus minimum number in that sampling or hour. Okay, this is the new example. It's different with first one. Okay, for example, X bar has been given to you directly 12 ohms. For example, average range or R bar is equal to 0.25. Sample size is n equal 5. It's a new example. Okay, it's completely different with one. I give you directly the given information. For example, in a company, the process average or X bar is equal is 12 ounces. The average range is or R bar equal is 0.25. But as I told you, the R bar is calculated or the range and the average of R or range. We should sum the range in each other or each sampling and divided them by the number of sampling or number of hours. And sample size is equal or n is equal to 5. Okay, from table. When n is equal to 5 or sample size is equal to 5, how much is the a and these 2? How much is a and these 2 or mean factor from table? From table. Please tell me how much is the a and these 2 when the sample size is 5. Very good. Yes. 0.577. When the sample size is 5, the mean factor is 0.577. As I told you, this is a new example. Don't confuse it with first one. This is completely new example, and I gave you directly only the numbers because we want to be familiarized with the new formula. Okay, UCL equal X bar plus A and these 2 multiply R bar. X bar is given to you 12 plus A and these 2 was determined in table 0.577. From table, when n was 5, point. I wrote in chat from table when n equal 5, a and these 2 equal 0.577. UCL. Okay. UCL can be calculated like this. LCL can be calculated also by formula. When you determine the UCL and LCL, you wrote them in the table, in the graph, you draw it in the graph, UCL, LCL, and mean has been given to you, X bar is 12. I repeat again, the mean or X bar is exactly in the middle of the UCL and LCL. When you calculate X bar, when you calculate UCL and LCL, and when you calculate the average of the UCL and LCL, for example, UCL is 12.144 here. LCL equals 11.857 here. When you calculate the average of them, for example, 12.144 plus 11.857 divided by 2, it produces 12. Exactly The same as the method you have calculated the x bar bar. On the other hand, the x bar bar can be calculated of the mean of x bar. When you calculate x bar, that is mean of x, you will reach to 12 again. They are the same. So when you draw the line of the x bar bar, UCL and LCL, exactly you can do as earlier. You should select or you should determine the point or spot on the table and see the process is under control or not. The rest of them is exactly the same as earlier example. Only in this method, because we don't know sigma, if you are working in the company that the sigma is not given to you, you can use this method to determine the x bar chart, and through this identify the process is under control or not. Okay. I think the time is over now, and no, there is no difference. No, no. Sometimes you have sigma, sometimes you have not sigma. If you have sigma, use the first formula. If you don't have sigma, use the second formula. Exactly the same, no problem. As I told you, this is the new example for second approach or second method. Yes, no difference. If you have sigma, use the first. If you don't have sigma, use the second one. Okay. Do you understand the lesson generally? Did you understand the lesson generally? I think I want to know, did you understand what we want to do? Okay. It was very easy. How about the lesson? Are you satisfied with the lesson? Okay. And are you satisfied with my lecture until now? Okay. If you have suggestion, if you have any suggestion or something like this, please let me know. If you have any suggestion or if you have any uh, criticize and something like this, please let me know. If you are satisfied with my lecture today, let me know, and if you are not satisfied, let me know. I told, yes, I told the academy to hold extra class because of Ramadan. I told academy to hold an extra class because of Ramadan, and that we can repeat again. Okay. Uh, if you have not any question, please let me. The class if has been finished now. The time is over, and we should leave the class. If you have any question, if you have anything, please let me know. I sent this PowerPoint and also location strategy and supply chain management to you. You can check your email and upload and download them. And also I sent The current PowerPoint, the chart PowerPoint, the control process PowerPoint to you. Okay, you're welcome. Okay, very good. If anybody have not received, if somebody have not received, please let me know. Please send me email. I wrote my email in chat. sabermirza@gmail.com. If somebody has not received the PowerPoint, please let me know. Please send an email to this email, sabermirza@gmail.com. Okay, to resend again. Okay, if you have not any question, class has finished now, and I wish everybody have a nice time with your family. Have a nice night. Okay. If you have any question, don't hesitate. Send me email. I'm at your service. If you have any suggestion and any something like about my lecturing and something like this, please let me know. I'm doing my best for your better understand, because I want to give you detail about everything, and I repeat again and again for better understanding. Okay, have a nice time and have a nice night. Goodbye, everybody. Okay, sure. I will give more examples next week. Goodbye, everybody.